Hi. There's been a lot of interest in the neural style videos I've been making, so I thought I would take an opportunity to publish the work I've been doing, or publish the techniques behind the work I'm doing, um, in my QLab. QLab is my series of videos where I talk about experiments in graphics. So this fits in nicely. Let's start with the Obscura videos. I think this is the first one. Okay. So what we have here is an animation. There is a base animation under it, which is one of my cellular simulation videos, which I'll talk about. But the primary coolness of the video is coming from the neural style transfer algorithm, which is incredible. Let me just, pardon me if this is old news to you. The neural style transfer algorithm, I stumbled upon it maybe a year and a half ago, and I've been obsessed with it ever since. Is invented by a man named Leon Gaddis, who was exploring using neural networks to do texture synthesis, which is an old problem in computer graphics, but he found this new way to tackle it using neural networks that are trained to recognize imagery. And it's genius. It's mind blowing how cool it is. The way I describe it to people who haven't heard of it before is Leon's idea is to take two computerized brains, two simulations of a model of our human visual cortex, cut them in half, and shove them together. So, and then create an image of what they see. And if that sounds Frankensteinian, I intend it to, because that's really what's going on here. We're taking these digital brains that we don't entirely understand how they work, but we can perform these crazy operations on them, like mashing them together, and see what comes out. And what comes out is cool. And I think that's due to the fact that these models do model the human visual cortex. And so the images that they create sort of tickle that part of our brain. Here's another one. I can show you these videos while I blather on. So again, the logo. So that's Obscura. Obscura is this another company, a company I'm working with in San Francisco that does video projections, large video projections, and they are super nice guys. And we're doing a project for Coachella, maybe. So that's very exciting. Here's another one. I created these videos to show them what sorts of things are possible. I took the Okay, well, there's some videos. I'll put these all online. So I'm going to put all of the files I show you today online. I may not put the style files online because some of them are proprietary, but you can use your own. Where's another one? 8. Was 8 any good? Oh, 8's kind of cool. Yeah, so this is just different input style images. You put it in a piece of artwork, and out comes an animation of that artwork. Okay, so how does it work? I wanted to run through this faster than I'm running through it. Okay, so let me show you. Okay, we're in QLab 5, and then the Obscura style. The first thing I want to show you is this. Okay, so here is the base underlying animation from which all of those logo animations are derived. It is the output of one of my cellular simulations. Maybe you suspected that from the appearance. But I talk about that extensively in previous videos, so I won't go on about it in this one. Although I will put the code for it online so you can drop your own logos in and see them come to life like this. And then the application of the neural style to that animation. Okay, so here is, actually, let me rename this just Obscura. Obscura. I had one of these folders for every video. I'm not going to bore you with all of them since I'm not giving you the styles. Okay, so read me. There's nothing here. Anim is the shell script that creates the animation. And it's really straightforward. It's ridiculously straightforward. It is about 2 pages of shell script. And basically what it does is for all the frames in the input animation, which again was that cellular simulation, it processes them for size constraints, and it passes them through. So the main bulk of the work here is just the neural style algorithm. I use JC Johnson's implementation from GitHub. It's very nice. I have a modified version that has a slightly different syntax for the for this bit. So if you do try to use this code, you'll have to change this bit here. He uses a slightly different syntax for his input image. So let me tell you what this input image is. When the neural style algorithm runs, it's an iterative process. And the trick we utilize to make these animations nicer is we start, instead of starting with some random noise as our first frame of the iterative convergence process, we start with the data generated from the previous frame. And that helps guide the algorithm to more consistent results. Normally, the algorithm's very chaotic, so the slightest change will cause dramatically different output. And it won't be that dramatically different, but it'll be jarring in an animation, 60 frame a second animation where they're flipping past. So what you want to do is you want to nudge it in the, I don't want to say the right direction, but the direction it took last frame. So that's what we do is we give it an input image, which is computed up here, and that's a blend using Image Magic for my blends, I think. Yeah, composite is Image Magic. Blending the input animation with the previous frame, and I think I blend them at 50%. Okay. And that's it. You iterate over the sequence. I think this one was frames. This was, I can't see it. It's probably in front of me somewhere. Anyway, the size was 1024. It was a big render. Okay. That's all I have on this. So let me show you, I guess I can quickly show you the montage video. So this was a survey of all the different animations that we produced. Actually, not all of the animations. So the first one is the raw cellular simulation, and then this is the one I posted. This is probably my favorite. When I posted to YouTube, this one's cool too. We added some music to go with it, and that was from a group called Adult Fur, who's been helping us create awesome soundtracks for our quirky videos. So here's the one I showed you secondarily. Are there any others? I think this is a longish video. Yeah, here's one. Maybe I shouldn't run through all these because I've got more ground to cover. But they're fun. Yeah, the animation, the movement that occurs, I don't want to call it the background, but the animation that occurs in flat areas of the input image is very interesting to me. It changes the motion, the movement. See, like these aren't moving very much. The movement is entirely generated by the input style, the artwork. Different artwork move in different ways for reasons I have no idea, but it's cool. That's a Kandinsky. That's also one of my favorites. This one's plants. This one is succulents. And this gives I mean, this is a good overview of what neural style can do. It can use any input and usually creates. So this, yeah. So the motion in this one is different from, and certainly than this one. The movement seems to follow the shapes in the input artwork. It's an interesting problem as far as I'm concerned. Okay, so enough on this. Then after I did those Obscura videos, I moved on to what I'm calling my Zoom series. It's effectively, actually, the videos for those are in a different folder. Run 4. Okay, so I didn't create videos for the first ones. Okay, so this is going in a totally new direction. The idea for these videos is you continually zoom in on a neural style render and then re-render it to see how the algorithm will affect the slightly higher resolution version of it, and it creates these cool, I don't know what to call them. All this stuff looks very hallucinogenic. This also is Pablo Picasso's face, and it's derived from one of his artworks. I sort of secretly hope that he would approve of this work. So that's 4. I have a bunch of these. This is sort of the same effect with a different style. And again, we're going in on his eye. One thing to note, if you didn't see before, is this cross, this up and down line and horizontal line right in the center of the image. And that's a process, that is a result of a bias that I'm having a little bit of trouble rooting out. I think I'm pretty sure that if I sort of put some noise in the motion, that sort of won't be able to stabilize like that. In fact, I have success at getting rid of it later. But that was an early problem. Here's another one with a style that we already saw. This is not a Picasso painting. Just let this run out. Some of these are longer than others. Here's one of Picasso with 2 of his paintings. Oh, so maybe this is... Okay, this is where I started mixing styles. All the previous ones were just a single style. This is 2 styles blended at equal weights, 2 of Picasso's paintings. And then I think this one, I also started making them smaller so that they'd render faster. Is this it? Yeah, this is it. It's hard to tell because the 2 styles are very similar, but it's a transition from one style to the other. So at the beginning of the animation, we get one style. Let's look at it big. At the beginning of the animation, we get one style, and over the course of the animation, we shift the blend weights so that it's a different style at the end. But the 2 styles are so similar, sort of silly. Here are 2 styles that are very different. This is Picasso's face. Can you tell? There's his eye. So this is a very graphic cubist painting, and then it transitions to It transitions to a more traditional oil painting in the end. So you can kind of see that transitioning happening. Okay. Let's just run through all of these videos real quick. So here's another animation. Again, you can see the lines. Now the line has moved down a little bit from the center, the horizontal line, because I am zooming from a slightly different point of view. You know what? That's probably means it's a good time to look at the code for how to generate this zooming effect. If it's not obvious to you, what we're doing is slightly cropping the edges off of the image in between each frame. Which one was this? That was, oops, crud. Not that one. I don't know, I can't tell. Oh, okay, so yeah, that's the surprise one. Okay, so let's go back to 10. 10 is just the flat zoom. Okay, so let's look at 10, run 10, and look at the code for it. Again, very similar to the one we had, the shell script we had before. C shell script, I know, sorry guys, I'm old. We loop over all the frames and we process them with the neural style algorithm. Oh, in this one, this one's interesting because we have 3 passes of the neural style algorithm. This is the upresing technique that Gaddis described in his most recent paper. My company Picasso has been using it for a long time, and that's why our command line switches are different. But now it's been published, and J.C. Johnson has put support for it in his renderer. It's a really, simple process. You render at low res. You take the low res render that you just produced, and you use it to initialize that convergence process. So again, we start with an already rendered image at a lower res, we scale it up, and then we run a bunch of iterations at a higher resolution, and then we do that again, and we run a bunch of iterations at an even higher resolution, and that's why these pictures are so big. And when you do it at high res, you can really see. I'm not sure how this will compress on YouTube, but you can see some interesting detail. There's a lot of detail. It's cool. But in between each frame, the real reason I came in here is this cropping. So we use the the shave operator in ImageMagick, and we shave off the edges, and then we chop a little bit more off the bottom so that the what do you want to call that, the perspective point isn't in the center anymore, it's down. Okay, so that was the standard zooming, which was done by cropping. And then I moved into a new kind of zooming, which was actually my plan all along. So in run 11 here, you'll see there is a new directory called warp. And what does warp do? So warp does this effect. It is, instead of just cropping the edges off, I'm actually distorting the entire image. And you can kind of guess how I'm doing it mathematically, probably. It's just distance from the center of the image, applied some kind of power function to it to move the pixels. Here, let's look at the code. That's in this warp directory. Like I said, I am using RenderMan to do the warping. RenderMan is, I'm actually using RenderMan. I'm using an open source equivalent to RenderMan. But the technology's been around for 30-ish years. It's what Pixar invented to do their movies. It's a really nice rendering engine. It's not real time, but it's very nice. So what I'm doing here is just using a displacement shader to move the pixels. And I do it by finding, so what is it? Vector L. Vector L is the distance from the center of the image, from the center of the world, actually. We zero out the Z component. We find its length, and then we use its length to divide out and find the normalized direction. And then we compute a new vector that is in the same direction but has a different distance, and that distance is a slight power function on the original input distance. And then we move the pixel, and voila. So the way to render these, what I use, so RenderMan is proprietary. Pixar sells it for a lot of money, but there are open source alternatives. I use 3Delight, so their render is RenderDL, and it's waiting for input. But rendering these is as simple as doing RenderDL on the rib file. Do. So you got to download that package, and it takes a while. So let's just stop it. Okay, I want to look at it again aesthetically, not technically. Two things to notice here. We're still getting, if you can tell, here you can, like back in the beginning. Let's pause it. Come on, stop it. Go back here to the beginning. We're still getting these biasing errors. You know, you can still see these two lines here, but much less so than before. But another problem is it looks like brown mud. Maybe another brown substance that's being extruded. It's we're losing all of our color in the middle, and that's actually happening for the same reason that when you mix all your paints together, they turn one color brown. We're mixing these. Ooh, why did my mouse get so big? That's crazy. We're mixing these colors together, and brown isn't an attractive color. It would be much more interesting if it were colorful. So let's see how we solve that. I don't think I solved that for a while, but I do create more renders. Here's another one. So this is where I'm doing like sanity test to see if the brown thing was just a one-time occurrence due to that style or whether it affects all styles. And it's affecting this style too. It's not brown, but it's an ugly yellow. When the input artwork is much more colorful. So somehow that's getting lost. And again, I'm putting all the code for these. So here's another one. Again, you can see that horizontal line, It's our man Picasso again, but he's being rendered with some Basquiat artwork, maybe? And the color's better. Is this the one where I did that trick? Yes, it is. Okay, so my idea to fix the muddy color is to, if you notice, the edges of this circle have now been pushed off screen. You can just see them a little bit here and a little bit in the corners. But in the previous run, you'll notice that the edges of the circle were completely contained by the image. What's the point there? One of the properties of the neural style algorithm is that it tries to create a consistent frequency of visual artifacts across the image, and if we show the edges of that sphere a lot of coloration, a lot of intense coloration gets pushed to the edge. And so to compensate, this is my theory of what's going on. I'm not entirely sure, but it seems reasonable. To compensate for the intensity in the edges, the neural style is making the interior sort of muddy. So what I did here was I pushed the edges off screen. I did that slightly. I did that in the math of the warp displacement shader. Okay, and my theory is that'll clear up the muddiness. And after I did that, the muddiness went away. So maybe that's actually true. Let's see, is this one? What is this? Well, that's that same one, I'm pretty sure. Or a mostly identical version of it. Okay, so here's a new one. What do we got here? So it starts with a Basquiat painting. Nice zoom on the eye. And we're fading into a Gustav Klimt painting here. I think it's only a half mix by the end of the animation. So you still have lots of Basquiat on the sides, but so the Basquiat stays in the sides, and then that means more Klimt has to be in the middle because there's the balancing aspect. That's kind of cool. It does get muddy though. I mean that's still muddy. I think I turned up the effect to try to get rid of that mud. The size thing. In the code, I call it flushing. I'm flushing the image data off the sides, or trying to anyway. So that's a cool one. There's no transition there. It's all Basquiat. I'm not sure what I was going for there. I could read the README, but let's not. Next one again starts with Basquiat. Oh, okay. So here's the reverse effect. Just negate that displacement shader, and instead of zooming in on the eye, we zoom out on the eye in the same sort of warping. So again, the Basquiat gets pulled into the center, and in the edges come the Klimt colors. Kind of has a painfully obvious bias to it. If you didn't notice the subtle horizontal and vertical bias in the other videos, this sort of diagonal bias, it it's it, you know I think it stands out. I'm pretty sure that stands out. Why would I want to reverse the effect? You're like, well, why did he even bother to do that? Let's see if I did it here too. Yeah, I did it here too. Why would I want to reverse the effect? I think I changed the flushing here to try to compensate for that X. And the X is, it's still obvious, but I think it's less obvious than it was before. But the question is, why am I pulling these images in now? Well, it's a cool effect for one, but for two, what I want to do is I want to reverse the frames. Okay, so if we play this backwards, we should make it bigger. If we play this backwards, it looks like the other animation, the forwards animation, obviously, but at some point we come back to the original image, which is Picasso's face. So the reason I'm doing this is I'm going to create two of these animations and put them back to back, reverse the first one, and so let's see. Okay, so now I'm choosing the styles I want. Here's again a reverse that will be reversed again. These styles, I'm using Picasso's paintings now. So this the style at the end of this video is one of his more traditional paintings, and the style at the beginning is his paintings have French titles, and I don't know how to pronounce them, so I won't embarrass myself. But this was a painting that was pivotal in his career. And then if we look at the next one, we start out with this, but then we zoom in, and we're using one of his more graphic later paintings, the bull. I don't know if you can see the leg of the bull sort of showing up there. And then the last one is, so I re-rendered this first bit. And we can see that reversing thing on this video here. So I'll just watch it. So what I've done is I've taken the reversed animation and reversed it so the direction of the flow is consistent with the second half of the animation. So we settle into that, and then we zoom in on the eye. Some of you have said in the comments that you'd like to see this go on forever. Yeah, that's totally the idea. This is a never-ending sequence of hallucinogenic images generated from Picasso paintings. So, you know, I think it's kind of fun. The last thing I want to show, so that was run 20. The last thing I want to show is run 21, which I don't have packaged up yet. But my goal here is to address the resolution issues. So a lot of those were very jittery. They were generated at low res. Now I'm doing that forward animation at a high resolution at a high frame rate. So this is 60 frames a second. Not sure how my video player isn't playing it very smoothly. I think it's probably because of my recording software. So, well, I'll publish this too, but it's not done rendering. It's halfway done rendering. And there's a lot of interesting detail in the high resolution. Okay. That's all I have for this video. Like I said, I'll put the code online, and I'm very receptive to questions. So, thank you for your time.